All right, let's get going. Got some experiments to do here today. Let's get everything set up. All right, get some water in these. Hope I don't mess this up. Try to get some water. Oh boy, I should have had the water in there to begin with, shouldn't I have? Hope I don't spill water everywhere. All right, here we go. Dump some in. Well, that's going to take a while. There we go. Sorry I can't really read the comments right now. Trying to get some water set up in here. Get there in a second. This isn't the easiest free-flowing water, I guess. I'll get to those comments here in a second. This is some cold water. It was sitting in the trunk of my car in the garage. It's going to be a little cold. Let's get the other one filled up. I'll bet that glass is going to fog up from how cold the water is. Getting there. All right, that's good enough. Okay. Whew. That's heavy. All right, folks. I think I can top that off just a bit. We got a nice little vortex going on over there on the left, eh? Let's get a little bit more over here. A little bit more over here. There, we're talking. Okay, now we're going to add the universal indicator. Universal indicator is also known as rainbow indicator. It displays these colors at different pH values. All right? And pH just tells you how acidic or basic something is. Okay, in goes the universal. Where is it? Right here. I don't think so, musical. I don't think that'd be a good idea. All right. All right, here we go. As you can see here, the universal indicator is green in color. Watch what happens. Hello there, Aslan. We're going to add a little bit of the universal indicator to this flask over here on the left. And you'll see a yellow color grow in, or develop, I should say. That yellow color tells us that the fluid is slightly acidic. That's not alarming to me, even though I use distilled water. You might think that pure water should have a pH of 7, which it should. But even water that's distilled is not pure, because if it's in contact with the atmosphere, some carbon dioxide will dissolve in that water, and it'll make it slightly acidic. So that yellow color you see that's developing is from the dissolved carbon dioxide that's in the water. All right, let's add a little more to this side over here. Just trying to get the color right. We want to get a nice color develop so we can mess around. All right, I think that's enough. All right, we got that set up. Got our universal indicator all ready to roll. And now we can start doing some experiments. Okay. I think I'm set. All right, let's try it. Here we go. I'm going to either add, let's add a drop of sodium hydroxide base to the left. See that violet color grow in immediately. That violet color tells us we've got a pH of like 10, right? Yeah? So we see that as we add base to the system, the pH increases. That's a well-known effect that we chemists see all the time. On the other side, we're going to add some hydrochloric acid. Hydrochloric acid is the same acid that's found in your stomach. It's just that this stuff that I'm adding is about 100 to 1,000 times more concentrated. So in goes 1 drop. You might see a faint red color developing. Sure enough, when it hits the bottom, you can see that red color, and there we have it. I do too, Natarade. So over here on the left, hey, Jake, come on, man. Talk about acids. Jacob Dunkel did a reaction with HF acid, so hydrogen fluoride. Tell me about that, Dunkel. What happened? So Jacob Dunkel, he's a chemist that I know. He's got his master's degree in chemistry, and looks like he did some experiments with hydrofluoric acid. That's some particularly nasty acid. What kind of experiments were you doing there, bud? Let us know. Natarade asks, how do I balance the pH in my soil if I have too much phosphorus? Not real sure. I need a little bit more information to help you out. So I'm going to go ahead and add a drop of base over here on the right. Sorry, Natarade, I can't help you out with that. I'm not 100% sure what all is in your soil. Just, the phosphorus amount doesn't quite tell me enough. But what I would do, let's see, if I wanted to, I don't know what pH you want your soil to be, Natarade. So yeah, we're going to add a little bit of hydrochloric acid over here on the left. Just a drop. There it goes. Got a nice little color change. It looks like we got a pH of 8 over here. We got a nice aqua color. I don't normally see that. Let's add another drop of acid over here on the right. Another drop of acid over here on the left. See all sorts of interesting colors. Yeah? Very beautiful. All right, I'm going to chase this over here with a little bit of base, a little sodium hydroxide base. Look at those flow patterns. You get some really interesting flow patterns sometimes that'll develop. Really cool, I think. Thanks, there, Natarade. I appreciate it. I just, if you can tell me what the pH of your soil is and what you want the pH of your soil to be, I might be able to offer some suggestions. Here we go. Let's add a drop of acid over here on the left. And of course, as we add the drop of acid, you can see the color change. It started violet, didn't it? Yep, started violet. We see a bunch of different colors as the solution is homogenizing. It looks like this over here stopped at like a pH somewhere between 7 and 8. So this is just maybe either neutral or slightly basic. And this solution over here went to a pH of about 6. There's our pH scale right here in the middle, yeah? Let me see if I can get that in there. Squeeze it in there. How much are the magnetic stir bar tools? They're about $40 a piece. Oh, nice. Bought about a acre and a half to grow some hemp, it sounds like. I don't know anything about what pH the soil needs to be to grow hemp, so I'm not sure I'm going to be able to help you out there. All right, let's try her out, man. Let's see what happens if let's add some acid over here on the left. Here we go, a drop of acid. And of course, we started at pH 6, and you can see it just, bam, it goes straight down to pH 3. Soda Pop asks, how does the human body produce stomach acid? The human body has cells in the stomach called parietal cells, and it's in those parietal cells where the hydrochloric acid is formed. So Jake Dunkel did a very small scale test reaction known as hydrofluorination. It's a way to add fluorine across an otherwise very unreactive double bond. Come on, man, double bonds are unreactive? I thought those were reactive. Shows you how long it's been since I've had organic chemistry. I mean, they're more reactive than, carbon-carbon single bonds, correct? I'm going to turn down the stir speed over here. What language do I want you to speak, James? Whatever language you prefer. I speak English. I apologize. It is the only language that I speak. So sorry about that for folks here from other countries. You're going to have to help me out. I'm going to go ahead and turn this stir rate down just a bit. And let's add some acid over here on the left. Like 1, 2, 3, 4 drops. Let's see what we get over there on the left. Oh, that's a quick switch, isn't it? Quick switch. Looks like pH 3 over here. We got that very acidic. So F says, I'm going into the life science and will be taking organic chemistry first year at university. What advice can you give? Attend class and do a lot of problems. The more problems you can do, the better. So problems out of the chapter. I am sure, your instructor will give you some problems to do. Que pasa con? I know I'm not saying that right. James, is that what's happening? You're welcome, F. I have no idea. I'm guessing. Y'all help me out. That looks like Spanish to me. What's university like? It's like high school, but you take responsibility for your own learning in a much more deep way. What's going on, Caleb? Good to see you here. Hello, Charles. Any tips for equilibrium? Lots of problems. Lots of problems. Many problems you can do. Hello, Fatima. How are you? I'm not getting. You know what? I'm wondering if things are a little different today because my water is a lot colder. The water I'm using was it was in my good to hear it, Fatima. It is harder. I mean, school it's a big jump. It's a big jump going from high school to college, but if you've been well prepared at the high school level and you take responsibility for your education, you're going to be just fine. You're just going to have to, you're just going to have to make sure that you do a lot of studying. That's all. What's the spinny thing, asks Matilda? It's just a stir bar. So here, I'll turn it off. So down here at the bottom, that's a little magnet that's coated in Teflon plastic. And this box here, the box that you see here, it's a magnetic stirrer. And the way I like to describe it is it's like a fan inside this box, and the fan blades are magnetic. So when the fan blades spin inside the box, it makes a little magnet spin, and that gives me a little vortex. James wants a rainbow. Come on, James. Let's see if we can do it for you here, buddy. Come on, let's see if we can get the rainbow going. I'm loving some rainbow when it happens. It's like a tornado underwater. That's right. Hey, Maximilian, what we're doing is I'm trying to make a rainbow. Let's see if I can do it over here on the left. And then I'll explain a little more detail. Come on, give me the rainbow. We got red and violet. No, I think I missed. We're going to try again. I'm going to add a little bit of red or acid over here on the right. Can I make it strong enough so it touches the spinny thing? I'm assuming you're assuming you want the vortex up high enough. We can try it. I'm going to try with this one over here. So what we're doing, by the way, all right, a couple people want to know what the heck's going on here, so let's talk about that. So what I have here are two flasks, and in each flask is some water, and they're on a magnetic stir plate, all right? You can see as I mess with these buttons down here, you'll see that this little spinner spins at different speeds. And in each flask of water, there is some universal indicator. Universal indicator is an acid-base indicator, and the color of it tells you the pH of the fluid. So this is violet, this is red. So the violet flask is at pH 10, the red flask is at pH 3. And then I just add acid or base to either one. So you can see over here on the right, I'm adding some base, and that neutralizes the acid. And that's going to, increase the pH. Let's see what happens. It might increase it all the way to basic. You got it. I will call you George. I will call you that. My apologies. So long, Caleb. So yeah, it looks like I overshot both of them. I'm not doing well getting the rainbow here. Let's try to add a few drops of acid to each. There we go. And you can see the pH goes from that violet pH 10 to the, whoa, it didn't quite go all the way down to 3 over there on the left, did it? It only went down to about pH 5. Breaking Dad. I'm loving it, definitely. I'm loving it. Breaking Dad. I can't wait to tell my kids that somebody called me that. I'm assuming you called me that. Maybe I should. Maybe I shouldn't assume. Yeah, you can do this at home, Raven. You could do this at home. Okay, let's try to get that rainbow going. So I'm going to add like 2 drops of base over here. Let's see what happens. Come on, man. Give me the rainbow. Hello, Ellieverse. Nope, we missed it. Thank you there, Stockholm. Come on, man. I got to get the rainbow for y'all. A little flash of it. It's usually easier to start at red and move in the other directions. I'm going to get 1 drop of base here. Come on, give me the rainbow. Give me the rainbow. Give me the rainbow. Little flash. Come on, baby. Yeah, I think this is stirring too fast. It's slower speed helps. Let's go like, I don't know, 3 drops over here. 1, 2, 3. Let's see if we get some rainbow over there on the right. Sandra, what I am doing is I am messing around with some universal indicator. It's also known as universal indicator, rainbow indicator. And what it does is it displays different colors at different pH values. And pH just tells you how acidic or basic something is. So right now, both of these are very basic. They're at pH 10. Hey, thank you for the subscription there, Raven. And what I'm going to do to both of these now, I'm going to start adding drops of hydrochloric acid. So I'm going to add 2 drops over here on the left. And watch what happens to that violet color. Hydrochloric acid is the same acid that's found in your stomach, by the way. There's a flash of rainbow. Come on, we got all the different colors at once. I love it. But you'll notice as I added the acid, the pH went from 10 down to about like 4. So as you add acid, the pH drops. I'm going to add another drop of acid over here on the left. I'm going to add 3 drops over here on the right. 1, 2, 3. Let's see what happens over here on the right. There's a smaller stir bar over here on the right, so the solution does not homogenize as quickly. Down here at the bottom, you can see it's pH 3, whereas up at the top, it's pH 10. We're watching the acid sort of homogenize throughout the mixture. And I already did that. So Nerlinger, I did make some piranha solution. You can check that out on some of the short videos that I have. Thank you, Fatima, for the subscription. Yeah, the Magic Cove. I put a Scrub Daddy in piranha solution. You check it out. It's kind of fun. Ten more days. Hey, there we go. Unknown. Perfect timing. Unknown says 10 more days till Christmas. And here, for those that celebrate, we got the Christmas colors. Perfect timing there, Unknown. Why is there not a tornado on the right? Because over here on the right, the stir bar is smaller. I'll try to turn it up. So I'm going to turn the speed up of this. Come on, baby. I don't want to drop. I don't want it to fall out of orbit. Wow, so that means this could dissolve skin because stomach acid would eat through you if it wasn't for a layer in the stomach. Sure, wanting brand. You know, if I spilled enough of this acid on me, it would probably start to irritate my skin. That's why I'm wearing gloves, because I don't want to spill this stuff on me, the acid on me, or the base. The base is caustic as well. I'm going to put 1, 2, 3 drops of acid over here on the right. That's correct, Ravens Queen. The smaller the stir bar, you'll notice the thinner the tornado that's made. I'm going to try to turn both of these to the same speed. So on the left, there's a larger stir bar. On the right, there's a smaller stir bar, and they are both at the same RPMs right now. Thank you, Poems. I appreciate that very much. Let's do a drop of base over here on the left. Got a flash of the rainbow, little 2 drops of base on the right. Let's get this. I want to get that light just a little bit better. I think I'm missing some of the, there we go. I'm missing some of the light at the bottom. That's much better. All right, let's do a drop of base over here on the left. I will, James. Here, we'll do it over here on the right. Watch what happens. I'm going to turn this all the way up over here. So James has to turn it all the way up, and that's what happens. So if I turn it all the way up, the stir bar gets knocked out of orbit. So it's really kind of not fun. But I can get it at a pretty fast speed without it falling off. This one, sometimes over here, I can get this one to go to max speed. I'm going to try it. Seb says, how about the chemical traffic light? Yeah, that's pretty cool. I don't have the materials for that. Thank you, Angel, for the subscription. I appreciate that. So I'm slowly turning up the stir speed over here on the right. So definitely once tried mixing vinegar and baking soda. Didn't like the smell of the vinegar, huh? All right, let's add 2 drops of base over here on the left. And let's add 2 drops of base over here on the right. And you can see it shifts to the violet color. I've almost got this max speed over here. And there it is. Over here on the right, I've got it max stir speed. Thank you, George. I appreciate it. So Raven Queen made something similar. That's cool. I don't think that can happen, Rogers. I don't know where you're at. Thank you, Angel. So Young Black, what we are doing here is, here I'm going to add some acid to both. So I'm going to add 3 drops of acid to the left, 1 drop of acid to the right. So what I have here are 2 different flasks. Both of them have universal indicator in them. Universal indicator is also known as rainbow indicator, and that's because it displays different colors, the colors of the rainbow, at different pH values. So you can see over there on the left, it's at a pH of 10, violet, and over there on the right, it's like a pH of 8 or 7, which is just slightly basic or neutral. Hello, MC. We got some from South Africa in the chat. Watch what happens as I continue to add acid. I'm going to add a drop of acid to the left, a drop of acid to the right. And you can see as I add acid, the color shifts from more violet or green. Well, let me add 2 drops of acid to the left. So we went from a violet, all the way down to like maybe pH 5 or 4. So as we add acid, the pH drops. Hey, Murray, someone from Indonesia. Put a coin in the glass on the left. Do I have a coin? I do. It's going to mess everything up, but we can try it. Somebody wants me to put a coin in here over here on the left. It's going to mess everything up, but I got this United States penny. We're going to pop it over here on the left. In it goes. And now it's getting whipped around. James is Hawaiian. And it's going to be tough now with that penny in there. Do I have my own lab? Kind of. Got a little lab set. I don't think so either, Sandra, but somebody wanted me to do it, so I went for it. Thank you there, Dreer. Thank you there, George. There we go. We're doing okay. Someone from the Netherlands. That's awesome. Yeah, drop the flag, you know, the emoji flag of where you're from in the chat. That'd be interesting to see. See if I can guess, you know, from the flag where you're from. A soft taco in there. Don't have one, Rogers. Put a soft taco in there. Oh, man. I don't know what that one is. I see it Canada. I see China. I think that's Finland. I apologize. I'm going to have a hard time saying this. Azerbaijan. I apologize. I know that's bad. Someone from Kentucky. Got someone from England. That looks like Mexico to me. China. I think that's Finland. Canada. Ooh, the one. Man, you know, you are all showing my ignorance. I apologize. Some of these flags I don't know. I am very, very sorry. Brazil, I knew that one. Some are from Bangladesh. Some are from 3 different countries. That's interesting. Hello there, Sorty. Versus, I don't mess with lead compounds. Some are from Turkey. I think is that Kenya? Austin, Texas. Yep, Finland. I think that's Australia. Lazy, that's a green and a white and a green. I'm going to need some help. I apologize. Someone looks like from Germany. Someone from India. Hello. Someone from, it's a flag that's got a green background and a red circle in the middle. I apologize that I've seen that flag before. I can't place it though. Someone from Lapland. Texas and China. Some Germany. Very cool. All right, the commenter wants a double rainbow again. We're going to try it. Someone from Palestine, welcome. Welcome, everybody. Here we go. Let's even get the double rainbow. 1, 2, 1, 2, 3, 4. Let's see. No, I went too much base over here too quickly. Too much base too quickly. I think I may have got a little bit of rainbow over here on this side. Error, I can't get it out of there, but this is what I can do. This is what I can do, because it is irritating me. That coin over there is really bugging me. So what we're going to do is this. Let's do this. Let's get a fresh flask. Let's pop this off. Yeah. All right, we'll do this. Hold on a bit. All right. Oh, get our fresh flask over here. Pop this in. Get the stir bar in there, but not the penny. There we go. Yeah, that wasn't such a good idea. I agree. Okay. What would happen if I poured this water on me? Not a whole lot. The acid and base that's in here is very dilute. Can I add copper sulfate? I don't have anything with... I don't have any copper sulfates with me. There's some Turkey. Someone from Turkey. That's very cool. I think someone's saying they're from Germany, but I'm not sure. You have to forgive me. Happy birthday, Digson. Happy birthday, 8 years old. That's all right, George. I didn't know that one, Sorty. I apologize. I'm going to need some help. You all are teaching me. You all are teaching me. Do I have any acids you can add to the base? Country edits, I'm glad you asked. I have some hydrochloric acid. We're going to add it right over here to the base side. 1, 2, 3 drops. South Africa. Thank you, Esethu. I apologize, I'm not saying the name right. Czech. The Czech Republic. Yep. Thanks, Dr. Nobody. Yes, Siona wants me to explain the experiment. Let's talk about it. Bangladesh. Oh, that's the Bangladesh flag. Okay, here we go, man. I'm a little behind. Okay, so what's happening? What is happening is I have rainbow indicator, also known as universal indicator, added to both of these flasks. Rainbow indicator changes color depending upon pH, or how acidic or basic something is. So if I look over here, you can see that's yellow. That tells me this is pH 6. Ubaid, I'm saying it Turkey. I must not be saying it correctly. So, please feel free to give me a phonetical spelling of how I should be saying it. Turkey, is that it? I don't know. I'm having trouble. Is that the Netherlands? Kyloren? Anyway, so over here, we've got pH 7, that's green. And watch what happens when I add a drop of acid to the left. We'd start at pH 6, and now we're down to pH 3. I'm going to add a drop of acid to the right. Turkey. Thank you there, country. Turkey. And we see that also, when I added acid, it lowered the pH to 3. Right now, for me, it is about 3:30 p.m. Nigeria, Ezekiel, welcome. I am using magnets to stir things, error. Stefan's verse, I remember you. Turk Y-E, is that how to say it? Turk Y-E, Turk Y-E. Okay, now I'm going to add some base over here on the right. In goes 1 drop. And you can see the color change that occurs. Actually, I think that light works better like that. That works much better. We're going to add another drop of base. We see the pH went from 3 to 7. Another drop of base brought it from 7 to 10. I'm from the United States. Why does it change like a gradient and not altogether? Asks Siona. Great question. Well, chemical reactions take time. So you got to understand, I'm adding a single drop. So here, I'll turn this off. Let's just watch it. I'm going to add a single drop of base to the top over here on the left. So the base is very concentrated. So in it goes. There's a lot of base in here. And where that base is added, everything goes violet. Now we can see that the base that I've added, it takes time to spread out. It's not going to spread out immediately. It takes some time. I added it to the top, and so most of it is here on the top. What I do with the stir bar is when I turn this on, it mixes the fluid much more quickly. So if I turn this on, you can see that that violet gets mixed throughout the entire material. Thank you there, George. We'll do the same thing over here on the left. I'm going to turn off the stir bar. And over here on the left, I'm going to add a bunch of acid. So over here, let's see, some drops of acid. And the acid is a little tougher to see, but you might be able to see here in the middle, it's kind of red. All right? And that's because the acid is concentrated in this area. Now what I'm going to do is I'm going to mix this up. So if there's more acid present, the pH will be lower than 7. If there's more base present, the pH will be above 7. The higher it is above 7, the more basic it is. And the lower it is below 7, the more acidic it is. So let's mix this up and see what happens. So I'm going to mix it up. Hello, Ezekiel. Yeah, we can try another chemical reaction versus. Thanks there, Sativa. So you can tell, okay? We can tell that in this flask, there's more acid present than base because the pH is 4. Yeah, this is perfectly legal. Hello, someone from Egypt. Ooh, so it's true. Oh, my goodness. True. Kai Yi. I'm having such trouble, David. Thanks, Error, for the sub. Oh, my goodness. That's right. Without the stir bar, it's just going to be diffusion. Someone from Sudan. Hello. Country Edit says much slower. So let's go a lot slower over here on the left. All right. Siona, what am I using? I'm using over here on the left some hydrochloric acid for my acid. That's the same acid that's found in your stomach. You can see me adding it over here to the left. And I'm going to turn off the stir bar over here on the right. And the base I'm adding is sodium hydroxide. People sometimes call this lye. If you mix lye with oil, it makes soap. Stick a plastic cup in it. Why would you want me to do that? Here's a plastic cup, and you just stick it in there and get some of it out. Yeah, get a little bit out there. Look at the gorgeousness we've got. We've got a little rainbow going on over here. So Fan wants it to go. Hello, someone from India. Fan wants it to go faster on the left. Nice pun there, Natarade. Hello, car guy from England. Hello, Da. World of Candy. I hope you like the video I made for my followers from India. I made a little chemistry experiment for y'all. I hope you like it. Check out my, hello, Da from China. Do I have science articles? I do. Forgive me, I'm not going to say your name correctly, but I'm guessing it's Poma. That's the way I would say it in English. I apologize. Isn't hydrochloric acid, doesn't have a pH of 2. It depends on the concentration of hydrochloric acid. George, I don't know much about space. I do know a little bit about the chemistry of space in the solar system. Hello, Alberto. Hello, Poems. Thank you there, Rogers. Hello, Dan the Man. Make it red then purple, says Random Videos. All right, over here on the left, we're going to turn this on. I agree, Error 404. Hello, Masid. So it's red, and now we're going to make it purple by adding base. That was the request I saw, so in goes some base. We're going to get this to go violet. A little rainbow flash there first, which is kind of cool. United Arab Emirates, hello? Although I thought you just said you were from China. I'm getting mixed messages there. Hello from Alberta, Dalton. Thank you there, Fresh Start. I agree, Fatima. Totally agree. Is there a way to go higher than 3? I assume you mean more acidic than 3. Yes. The issue is that the indicator will be red from pH 3 on down. And so I cannot differentiate between different pH values from 3, 2, 1. It's all red. And then you got it, Random Videos. And then above pH 10, it's all violet. So, shot, what is happening here? Max, go ahead and ask your question. Acrin, I will do so. I will do so. I will call that acrin. So what is happening here? Yes, I'm a teacher. So what's happening here is I have two flasks, both of which have universal indicator. Universal indicator is also known as rainbow indicator, and it tells you the pH of the solution. So if you look here, you see different colors, and with each color is associated a pH value, and that'll tell you the acid, whether it's acid or base. Phthalate, or phthala, I apologize, I'm not saying the name right. I cannot make it colorless. That's what I've heard there, George. God for real, I am using 20% by weight sodium hydroxide, and which I'm going to add to both right now. And the acid that I'm using is 20% by weight hydrochloric acid. The other 80% is just water. Can I name an airplane that you can make a video about? Man, I don't know many airplanes there, Max. Let's go with a 747. I don't know a whole lot of them. Hello there, Pancake. Roman, thank you, country. I appreciate that. Thank you for the help. I need a lot of it. Hello, Nadir. Hey, someone from Germany. Hello there, chicken. So if you go lower than 10 or higher than 3, the color will... Yeah, but I'm not sure I can really see it going on random. Thank you there, Pancake. Hello, Oliver. Hello, Aiden. Thank you there, Earth. Hello, Jude. Is there any other category than acidic, alkali, and neutral? Judea, yes. There are other category ways that we categorize matter, but acidic, basic, and neutral is just one of the ways that's very useful. Hello, Rashid. Welcome back, James. What's up, Glenn? Hello, Jude. Can I name stuff with a pH of 14? Indeed, I can. This sodium hydroxide solution that I'm adding is like pH 14 or higher. It's really, really, really concentrated in a base, which is the opposite of an acid. Hello, Aubrey. Have a great day there, Max. Hello, Starlight. Hello, Aubrey. Rashid's saying they're a fish. Can I tell you the difference, Siona, between pH paper and litmus paper? I apologize. I'm getting a little behind on the comments, so I'm going to have to speed through. Litmus paper just shows two colors, red and acid or blue and base. pH paper is more like this. It can show a variety of colors. It's cool, Swaggy. That's really cool. Thank you there, Pancake. Hello there. What's the highest and lowest pH you can get? The car guy. I think the lowest pH you can get is fluorantimonic acid, which goes like -26. It's crazy. Crazy low pH. On the high end, I don't know. Trivgun, I don't have any copper 2 sulfate with me. I apologize. Country edits. Oh, we got the rainbow, baby. What's my favorite experiment and why? Ask Country Edits, which is whichever one I'm doing at the time. Thanks, that one, for the subscription. Yes, Error, I am familiar with Tesla coils. I actually own a couple of them. Can I explain what's the difference between an acid and a base? Phthala. Yes, I will try. Can oil be acidic? I think so, like fatty acids. They can kind of be considered like oils that are acidic. So the question was, can I explain the difference between an acid and a base? So the way we chemists think about acids is they are substances that donate ions called H+ ions. H+ ions. And bases, you can think of those as substances that produce hydroxide ions or OH negative ions. Well, if you take H+ and add it to an OH-, those vigorously react and they form, well, let's see, an H+ and an OH-, that makes H2O, which is water. So an acid is a substance that increases H+ ions in solution. You can also think of a base as a substance that takes H+ ions out of solution. Thank you, Roman. Does acid or base stain other neutral matters? Jada, I apologize. I don't understand the question. Is my favorite element technetium, asks Aubrey. It is not. My favorite element happens to be hydrogen. I am Fatima. Why don't you all drop your favorite element in the chat? What is your favorite element? That's correct, Siona. Acid and base react to form water and salt. That's correct. Country edits coming through for me. I was off. I said that fluorantimonic acid has a pH of negative 26. It looks like I was off by about 5. So it looks like fluorantimonic acid has a pH of negative 31.3. I appreciate the correction. Silver, sodium amide, that's a compound. Carbon, uranium, arsenic and tungsten with the runner-up. Nitrogen, plutonium. We got all sorts of elements in the chat now. Gold, molybdenum. Are things like blood also elements? Blood is a mixture. Blood is a mixture. Titanium, says Roman. Nitrogen, says Fatima. Gold, says the Buddha. Lithium, says Carlos. Titanium, Fatima. Quicksilver, a little bit of mercury there for Amadeu. Oh, I love it, Aurora. I've never heard that before. What a wonderful way to remember. Ag, silver, is almost gold. Arsenic and iodine. Tantalum, silver, cesium, potassium. Element 116. Tungsten, thorium, plutonium, thorium. The element of surprise, Andres. I love it. Magnesium, oxygen. What's the mixture of blood? Boy, that's got a lot of stuff in it. It's got hemoglobin in there. It's got bicarbonate. It's got phosphate. It's got all sorts of stuff. Uranium and looks like glucose. Country edits is their favorite compound. Astatine, cesium, lead. Loving it. We got a bunch of chemists in the chat here. Ooh, do you know what is the most acidic thing naturally in your body? Probably hydrochloric acid. So probably the hydrochloric acid in your stomach is what I would guess. Country edits, C6H12O6 is indeed, it is glucose or blood sugar. Sodium polyacrylate. What is considered an element? An element is a substance that is made of only one type of atom. One type. So it's all hydrogen or it's all oxygen or it's all carbon. So like diamond is an element because it is only made of carbon atoms. Kind of cool. I just did a video on how, I haven't uploaded it yet. It hasn't gone live yet, but I've made a video today. I finished it up on how ice and diamond are similar. Thanks for Swaggy. That's cool, Fatima. What am I going to do, Roman, with these fluids? I save them. Thank you there, Swaggy. I save them and then just reuse them. So I'm just going to reuse these. I agree, country. That's correct, Prahlad. Buckminster fullerene is also carbon allotrope, just like diamond and graphene. And then there's all the carbon nanotubes. Like, there are so many allotropes of carbon. How do we differentiate between normal acids and bases and conjugate acids and bases? In other words, can every acid be a conjugate acid with its base, or is it only some? So it works like this. When acids give protons, okay? They donate protons. And when an acid donates a proton, it becomes its own conjugate base. So when HCl, which is an acid, gives up an H plus ion, it becomes the chloride ion. The chloride ion is the conjugate base of hydrochloric acid. That's the way it works. Another way you can define sort of a conjugate acid-base pair is a conjugate acid-base pair are two molecules that differ only by the presence of a single proton. So if you add a proton to a conjugate base, it becomes its conjugate acid. If you take a proton away from a conjugate acid, it becomes its conjugate base. Kerosene is neutral, country edit, so it doesn't really have a pH. It's just neutral. So what am I doing with... Thanks there, Fatima. Thanks there, Aurora. Swaggy asks, what liquid am I using in the beakers? This is just water. It's just water. But to the water has been added a special mixture of dyes called universal indicator. And the universal indicator is what allowing me to change the colors. So right now I'm adding acid to both flasks. And you can see as I add acid, we go from the more violet and blue down to the reds, orange, and yellows because everything's becoming more acidic. So adding the acid, and now I'm going to switch it up. Instead of adding acid, I'm going to add base. I saw someone ask the question, what does conjugate mean? What a great question. I don't know what conjugate means. I have no idea. I have no idea what it means. I know what conjugate acid means, and I know what conjugate base means, but I do not know what, the context of the word conjugate. What a great question, man. If any chemists in the chat know sort of how to describe conjugate in the absence of, using the terms acid and base, I'm interested. Triv Gum, I do have some luminol, but not here with me. Thank you there, Aurora. With the universal indicator, am I correct in saying that it stains anything? Yeah. Got it. So Aces is asking, does the universal indicator stain stuff? Kinda. It's easily washed off, though. I mean, it's really easy to wash off. So to say that it stains something, maybe. Yes, Swaggy, things are sour, like acids taste sour, bases taste bitter. No, Country Edits. So Country Edits, whether you can drink something is more complex than whether it's simply acidic or basic. So some things are neither acidic nor basic, like ethanol, the alcohol we drink, or isopropyl alcohol, which is an alcohol you shouldn't drink. So, there are a variety of effects on the body that can occur with various chemical compounds that have nothing to do with acidity or basicity. Aubrey, best advice for an honors chem student is to find a way to love it. And if you can't find a way to love it, just make sure that you practice a lot, as much as you can. So long, unknown. Why does the stomach not get burned by stomach acid as error 404? It's because the cells in the stomach produce mucus, snot, so to speak, that lines the cells of the stomach that keeps the stomach from digesting itself. Geographic lens. I think the difference between those two are where you are in the world, right? Favorite isotope? Probably hydrogen 1. How do we differentiate between normal acids and bases and conjugate acids and bases? I already, sorry, Yatniel, I thought I already answered that. Yeah, probably not a good idea to drink 100% ethanol. Geographic lens. The difference between those two words depends on where you're standing in the world. Because if I use the word formula in America, everybody knows what I'm talking about. But in Britain, they're going to wish that I used the term formulae. Oh, wait. Could be the plural, too, right? If acids are sour and bases are bitter, what is sweet and sour? I love it. Well, sweet and sour would be like glucose mixed with some sort of acid, like glucose and citric acid. Like, lemonade. Lemonade is sweet and sour at the same time. Favorite element? Hydrogen, baby. Fantasy Boom. What I added to make it violet was some sodium hydroxide solution. So when I add base or sodium hydroxide, the color is going to shift this way. Now I'm going to add hydrochloric acid, which is the same acid that's found in your stomach. I'm going to add 1, 2, 3 drops on the left, 1, 2, 3 drops on the right, and you can watch the color shift from violet to more orange, red, and maybe greens. pH of glucose, Aubrey, is neutral, so glucose is neither acidic nor basic. Fala, this is my setup. I mean, this is it. Yep, Gabby, I remember you. I need a little more information what you mean by can you see the setup. Do you mean, set up the experiment from scratch? $3 a.m. in the morning for fresh start. Sarah asks, what is happening to the molecules? Gotcha. We can do that here in a second, Fala. So what's happening to the molecules? Okay, I can give you a basic idea of this. One of the dye molecules in here is called phenolphthalein. So you got to understand, you're seeing the combination of the colors of 4 different molecules in each flask. So universal indicator has 4 different molecules in it. One of those molecules, and I talk about this one because it's the simplest one to talk about, only displays 2 colors. It's either colorless or pink. And that particular molecule is called phenolphthalein. Phenolphthalein. Now, phenolphthalein in an acid, as long as it's like pH 8 actually or below, it is a ring-shaped structure. And in that ring-shaped structure, it actually grabs onto a proton. And there's lots of, I'm saying the phenolphthalein is like this ring that I'm making with my gloved hand. And this white thing, I'm envisioning this or representing this as a proton that comes from an acid. So when there's a lot of acid around, phenolphthalein grabs onto that proton and it makes a ring shape. And in the ring-shaped form, phenolphthalein is colorless. Now, when there's a lot of base around, base takes protons away. Base accepts protons. So when there's a lot of base around, the proton from the phenolphthalein gets taken away. And when that happens, the phenolphthalein goes doink like that. It opens up. It goes boop. And as it changes its chemical structure, as it opens up, with that change in structure comes a change in color. Colorless to pink. Colorless to pink. And that gives you an idea of what's going on with all the other things that are happening. Thank you there, Karsak. I do not country edits. Technetium is cool, Micah. I'm agreeing. Thank you there, Sarah. How do you make this? It's very simple. Very simple. You just take some water. You add some universal indicator. That's it. And then I'm going to add acid or base. Swaggy carrot, the most basic thing I've ever worked with is concentrated sodium hydroxide. I do not country edits. I don't have any of that. The most acidic thing I've ever worked with is probably sulfuric acid. Sulfuric acid is very, very concentrated sulfuric is very acidic. Pete, welcome back. I've seen you around the chat or the the live stream before. I apologize. I don't understand your question. Does any element stain the body? Silver will, Ben. Yeah, add a solution of silver to. Maybe you've heard of the blue man. George, I don't understand the question. Where did acid come from? I apologize. I don't understand the question. Does hydrogen peroxide have a pH? It is neutral. It does not. Ben, I would say silver stains the body. I would say iodine stains the body. Walters, I got my PhD from the University of Michigan. So that's where I got my PhD, and I studied chemistry indeed. What happens if you get sulfuric acid on your hands? You put baking soda on as quickly as you can, the car guy. Question, why does the pH change the color of the water? Fatima, it doesn't change the color of the water. It changes the color of the dye that I added to the water. With phenolphthalein, when it goes between the 2 molecular shapes, does each have a distinct spectral line, or is it a gradual transition? Each has its own individual, we would say, absorption spectrum, Pete. So it's sharp, but what we see on the large scale is a gradual change because it's not like every single molecule transitions at the same time, right? There's a population of molecules, right, in the flasks. So there's not... And, there's a crap ton of them. I mean, molecules are just, there's so many of them. And so not all of them are going to change at the same time. And because of that, to your eyeball, it looks like a gradual change. But if I had a pure sample of the ring-shaped phenolphthalein, that's going to have a markedly different absorption spectrum, the way that it interacts with light, than the open form of phenolphthalein. Yes, that's right, Yatnel. Failing solution is not, I don't know if it's necessarily a complex, it's a solution. Name a country for an edit. I don't understand what that means, but I'll just say United States. Is there a limit to how acidic something can be? The Psy guy. That's an interesting question. I would say yes. And I would say yes because in my head, and that doesn't mean this is the only way to think about it, but in my head, a way to define an acid is something that is very good at donating protons. And so whatever is the best thing at donating protons in the universe, that's the thing that's going to be the most acidic. Apple Center, is bicarbonate a base? Yes, it is, and it is also an acid. It just happens to be a better base than an acid. I sound like Peter Griffin if he had a PhD. I hear that a lot. It must be a Midwestern thing, huh? I like molecules and I'm eating quinoa. Oh, man. Oh, very cool. Hey, man, it's getting time for some pretty good football games. I'm going to have to quit this live stream. I'm really liking the effect that I'm seeing over here. I apologize. I'm going to just... Am I using bromethymol blau? Yes, one of the indicators in this system is indeed bromothymol blue. Sorry I'm saying it the way that we Americans say it. Thank you there, Fallen Zoe. Appreciate it. What's the coolest experiment I ever did? All right, here's the coolest experiment I ever did. Here's what I did. I'm, you know, I worked at a really small institution for a really long time, and I still wanted to be able to do experiments. But, I couldn't get funding to do anything. It just, you got to be at a large research institution to be able to get a bunch of funding to do stuff. But I still wanted to be able to, study something. And so what I did, I was like, you know what? I'm going to use my knowledge that I got at the University of Michigan studying physical chemistry to actually study a system. And what I decided to study was the Koch and Mentos experiment. And it's crazy. You can look this up. I have published 10 articles on the Diet Coke and Mentos experiment, okay? So, one of my experiments, I think it represents the most fun I ever had doing science. What I did, and I've done this several times in several different contexts, what I did is I carried out the Diet Coke and Mentos experiment at different elevations all over the United States. We went from below sea level in Death Valley to the top of Pikes Peak. That's the highest elevation I've ever run the experiment. And we studied, not only did we study, the effect of elevation, which was interesting enough. I mean, it does what you think it does. It works better at higher elevations. I was also able to use some solid physical chemistry to describe the mechanism of how the Koch and Mentos experiment does what it does. Why is the foam produced? What's going on with the bubbles? So that's what I did. Thanks for listening to all that, me jabber on about that, but I appreciate the question. Come on, Prahlad, I agree with you. What's the most dangerous compound I've ever worked with? Country edits? Probably sulfuric acid, concentrated sulfuric acid. Well, actually, I did use piranha solution once, which is worse. I made a video where I put a Scrub Daddy sponge in piranha solution. Swaggy, I'm sorry. Yes, Swaggy Carrot. Can I set up the experiment? Let's go for it. Thanks for being patient with me. Okay, so you're all going to have to forgive me. Piranha solution is just a mixture of hydrogen peroxide and sulfuric acid. So you're going to forgive me. Yeah, true, Lux. I've used bromine, but I used bromine in a sealed flask, so it wasn't that nasty. Okay, so I'm going to set up the experiment here. You're going to have to forgive me. I'm not going to be able to read the comments as I do this, okay? So here's the flask, all right? You can see it set up on a stir plate. It's got a stir bar in it. There's your stir bar, all right? And we're going to turn on the stir bar. And then I'm going to add some water. You got to forgive me. There's a really big bucket of water here. So this takes a bit. All right, let me get this open. We're going to pour the water in. Okay, in it goes. Forgive me, I can't watch the comments and fill this bucket at the same time. And I gotta, you know what? I wonder if I can just take this thing off. Oh, it's not gonna let me. Come on, man. It goes so much quicker. Nope. Ah, rats. All right, I gotta do it the old-fashioned way. Come on, baby, get filled. People are waiting. Almost. Almost at the top. All right, that's enough water. Okay, so I got that all set up. And now, I'm going to add some universal indicator. Here's the universal indicator I got. All right. I'm just going to, here, let's top this off. Where's the, here it is. I want to top this off. There we go. Okay. Okay, here we go. Universal indicator. Where's my, here it is. All right, you can see this. And here, remember, here's your different colors that universal indicator is going to display at different pH values. So you'll notice that the universal indicator, when I first draw it out, it's green because it's neutral, all right? But watch what happens when I add it to the water. Oh, okay. It usually turns yellow, but there was some residual acid left in this flask, so never mind. It usually turns yellow, and it's yellow because of dissolved carbon dioxide. But anyway, I'm just going to add a little bit of universal indicator, like 3 squirts, so I get a nice color. The other thing that I do is I, to make it look pretty, I put a flashlight that looks like this. There's this flashlight that I stick behind, so I stick it behind here. I'm putting it on the other side, but there's a flashlight back there on a white background, so that it just looks kind of pretty. Here, I'll turn it off. This is what everything looks like if the lighting's not right. Let me turn all the lights off. I mean, come on, look at the difference. Isn't that crazy? So I'll turn this light off. I turn the room light off. I turn this light on. I turn the back light on. I turn this light on, and it just makes it really shine. All right, and you just play with the lights a little bit so you get a nice looking color. All right. Then what I do is I get 20% by weight sodium hydroxide and 20% by weight hydrochloric acid. And I'm going to add a drop of 20% by weight sodium hydroxide. Up here at the top, you can see me adding it, and it goes. You just watch the beauty happen, man. That's it. And then I'm going to add a drop of hydrochloric acid up here at the top. 1 drop. I'm going to add another drop. And you just watch the magic happen, man. That's gorgeous. Gosh, that's gorgeous. No, I don't have any luminol. Thank you there, Def. I'm going to turn this down, turn the stir rate down. And sometimes it's fun just to do this. Random question, but why does the bubble under the tornado stay in the same spot? So, Swaggy, what's going on here? Here, I'll do this first. I'm going to add a little bit of base here. So, in this tornado, so to speak, this vortex, let's look at this one for a bit. So this is a lot like a hurricane. Here, let's look at it from the top. Let's turn it up just a little bit quicker. So a little bit like a hurricane. So, there's a vortex here. And just like these, here, it's probably easier on this one. So let's get this one going. Come on, man. Get the vortex going. And so you can see it a little better, I'm going to add some acid. You can just see everything better at the lighter color. I'm adding acid. Come on. There we go. So I can see it much better now. Okay, so we got the vortex going on there. And just like the eye of a hurricane has low pressure, the eye of this vortex is also low pressure. Now remember that material moves from high pressure to low pressure. So anytime I stick something in here, it's going to tend to move into the center of the vortex. And that includes the bubble that you see. And that vortex, it goes all the way down, right? Look at it. It goes all the way down. So any material that gets trapped in that vortex is going to tend to stay there. Let's see if we can get a bubble trapped. So all through here, there's like a column that goes all the way down. There they are. You can see. Can you see those? Let's see if they're there. Yeah, look at them. There they are. There's some bubbles trapped in the vortex, baby. Right? And that makes sense because, you know, from the top of the vortex all the way down, there's a low pressure system. And a bubble, which is basically gas, it's not going to move to a higher pressure region. It's going to stay in a lower pressure region. Now watch, you can even see this when I'm going to add some base here. I'm going to add 1 drop. Look at where the material goes, and it stays right there in the middle. It's now, of course, when it gets down here at the bottom and it hits that stir bar, then it gets pushed out along the sides. But look at how stable that flow is. It's just a low pressure system. I'll add another drop. We can see it happen again. There it goes. Now, of course, this is a pretty turbulent system, so you're going to see, you know, some mess. But nevertheless, I can still see that stable, low pressure column. Hey, y'all got to see the rainbow, man. That was beautiful. It's really looking nice. Yeah, I've made ammonium hydroxide. I'm gonna stop streaming here pretty soon. I'm getting burnt out. I'm getting tired of looking at a screen. Fatima, when did I really start experimenting and doing science? When I got my first teaching job, which was teaching middle school science, I tried to do an experiment for my students, and I tried to allow them to do lab experiments in every class that I taught. And of course, when you're setting stuff up for students, you got to make sure it works. And so I spent an enormous amount of time, you know, doing experiments, getting ready for my kids. Error. Hydrogen peroxide does not have a pH color. It is neutral. It's not affected by pH. All right, well, pretty soon I'm going to be flipping this around, so fair warning, if you don't want to see my ugly mug, it's time to get the heck out of here, because it's going to be coming soon. And I just sit and chat with folks for about 10 minutes or so. Thanks there, Mark M. I appreciate that. That's a really high compliment. I don't know if you intended it that way, but I'm taking it as one, so thank you. The Psi guy asks a very interesting question. What is the most complex molecule known to science? Well, here's why I think it's an interesting question. How do you define complexity? Right? I mean, in order to answer that question, I need to know how you define the question complexity. What does complex mean? Yeah. I like the answer, Tulox. Carbon nanotubes, maybe. Swaggy, I've done that too. You're usually no worse for the wear. The light and frost effect protects you. Not happening, Flame Guy. Look at that rainbow. I'm not drinking it because one of the dyes is a laxative. What's the hardest material to work with? The hardest one I've worked with is probably concentrated sulfuric acid. So long, Air. Human DNA, Nick. That's good. That's a good. You know, depending on how you decide to define complexity. I am Flame Guy. But yeah, I want to know how we're defining complexity before I answer the question. I think that's fair, right? That's what we do in science. We make sure we're real clear on our definitions before we go pontificating about things. Mark. Mark wins the comments. That's hilarious. I'm loving it. I'm burritos, Arturo. How about you? Complexity formally is defined as having the most possible states, says Pete. Hang on a bit. I'm not. So, is that true, Pete? I mean, seriously, is that like, because I see having the most possible states, not necessarily the number of ways that you're existing in those states. Those are two different things. So here's the thing then, Pete. So here's the thing, having the most possible states. A hydrogen atom has an infinite number of states, correct? An infinite number of electronic states, because a hydrogen atom can have n, the principal quantum number, be anything from n equal 1 to infinity. So you would have to have some molecule with an uncountably infinite number of states to be more complex than the hydrogen atom. Tim, are you with me? Or Pete, are you with me? Go ahead, George, ask the riddle. All right, I'm flipping this around. Turn this off. Got my reading glasses on so I can see what the heck is going on here. You got it, George. Ask away. What's your riddle? Can the pH level go higher than 3? I think you mean, Fatima, lower than 3. Yeah, it can go much lower than 3. No, I'm not repeating. No, sir. I know how that goes. Yeah, that Tulux, that is what he means. How many states the molecule can potentially be in, or is it how many states the molecule is currently in at the current time? And the thing about that is if you define it as how many states can the molecule be in at the current time, now you're talking about the entropy. So the number of ways that quanta are stored in a molecule, as that number goes up, so does the entropy. And now what you're doing is if you do that, you're defining complexity as being synonymous with the entropy. And people usually don't like that, right? The more entropy something has, we, colloquially say, the more disorder it has. So how are we going to sort of relate disorder with complexity? I think there's an issue there. Good night, Naveen. Great having you along. Hello, Giat. I apologize if I didn't say your name correctly. So, Pete, you are saying it's like the entropy. Is there a limit to how big a molecule can get? What an interesting question. Okay, I like that, Sci Guy. What an interesting question. Is there a limit to how big a molecule can get? So, Sci Guy, you should recognize that chemists have a really hard time defining what a molecule is. If you look it up, I don't think we really can define what a molecule is. And I'm going to say that because there are some chemists who think that ionic crystals, so like sodium chloride, there's some chemists who say that sodium chloride, which is made of sodium ions and chloride ions, that does not exist as molecules because the sodium ions and the chloride ions, there's not an individual sodium chloride packet ever. Rather, there's an infinite array, or, it's not infinite, but practically speaking, there's just a bazillion of these sodium ions and chloride ions that exist in a three-dimensional array that we call a crystalline lattice. Now, there's some chemists who say that an ionic crystal itself is a molecule, the whole crystal. I know some of the chemists who think this. I don't like the idea. I just say, ionic substances don't exist as molecules. But there are some chemists who say that the whole ionic solid is a molecule. And if you take that approach, then a huge crystal of sodium chloride is a single molecule. It's like a gigantic molecule. So in that sense, there's a practical limit to how large a molecule can get, but there's not a theoretical limit to how big it can get. Gabby, what's the most dangerous chemical compound known to man? I'm telling you what, I'm not sure about this, but I sure would not want to mess with dimethylmercury. Good night, Swaggy. Is there any limit to the number of carbon atoms and hydrogen atoms in an organic compound? Dr. Hayes, I don't know, man. I am not an organic chemist, so I am not touching that one with a 10-foot pole. I do not know Tyler, the creator. So long, Fatima. Thanks for hanging out. What am I working on? Hudson, I was just doing some experiments today with a universal indicator. Hey, Drip T, thanks for stopping by. Hey, look who's come to see me. She's bored. She's like, you've been streaming too long. Come pay attention to me. You've been streaming too long. Complexity is in the most number of possible paths to get to that state. Pete, I'm gonna have to think about that for a while. It sounds to me like that's a pretty complex definition. You're gonna have to forgive me. I'm gonna need some help and some equations before I can talk about that. Thanks there, George. Yeah, thank you there, Hudson. Thanks, Devon. Thanks, Tulox. So long, George. Pete, under that definition I was talking about, yes, diamonds would be, a diamond is a single molecule. I have, isn't me? I love Breaking Bad. What a great show. What a great show. Okay, folks, it's been fun. I'm taking off. Time to get out and stop looking at a screen. I appreciate y'all hanging out with me and checking out some of the beauty of this universe and just a simple flask. It's amazing all the cool stuff we can see. So, pay attention to the world around you. This beauty's all over the place. Appreciate y'all. Love y'all. Thanks for having fun. And we'll see you next time. So long.